Hey everyone, it's Mrs. Lawrence. I am back with task 7, writing linear equations. So they've told us in task 3 we've identified direct paths between various park attractions by drawing them in with red lines. So whatever line color you chose, remember I used orange, it does not matter, but that was, we connected those points. So when we connected the toddler area to concession stand, it looked like this. Now we're going to show off our skills by writing equations for each of those lines. Again, it says red, whatever color you use. So we're going to find the equation of each of those lines. So it's asking us to use a linear equation y equals mx plus b and solve for b, which remember b represents the y-intercept in our equation. So our y-intercept, we're just going to cross the y-axis. We're gonna use our slope. So we found slope in task 3. So task 3 was where we found the slope. So I'm gonna write this in here. Found in task number 3. So found that in task number 3. And then, I didn't read enough because it says from task 3. So should have kept reading. So from task 3, and one of the identified endpoints of that line, so x or y. So when they talk about the endpoints, so you're going to use one of the two ordered pairs. So a line they're going to have two endpoints. So either like here, I would either use the toddler area, that ordered pair, or the concession stand, that ordered pair, one of the two ordered pairs, to help me find the equation. Then says after solving for b, so solving for that y-intercept, we're going to write each red line's equation using only the value for slope and the y-intercept, leaving x and y as variables. So we're going to then write that equation. So the first thing I got to do is I need to solve for b. So again, focusing over here on the toddler area and concessions, because that has been our go-to for this project, for me explaining and trying to provide some assistance. So I'm going to solve for b for the y-intercept for my toddler area and concession stand. So my toddler area and concession stand, if I go back to task 3, here is what we did to find their slope. And our slope was -6/5. So that was what our m value was. So I'm going to write here, just so I don't forget, m equals -6/5. That was our slope. So our slope for this was that. Again, we are going to write it in y equals mx plus b. We already have m. It is -6/5. So I know it's going to be y equals -6/5 times x plus b. Again, we're solving for b. We don't know what this is. So to find b, I am going to take one of the endpoints from the toddler area and concession stand. So toddler area's point was 5, -3. Concession stand was 10, -9. It doesn't matter which of those 2 points you utilize, you will get the same answer. So I'm going to just pick toddler area. I'm going to pick 5 and -3 as my endpoints. So that is what it is telling me to do right here. Identify one of those endpoints. I'm going to utilize this one. And I'm going to replace the x value and the y value so that I will be left with just the variable of b, and therefore I can then solve for it, and I can then write my equation. So again, the first number is our x, the second number is our y. So y, I'm going to replace it with -3. Again, I could have used -9, I'd get the same answer. And then I'm going to have -6/5 still, because that was our m value. And x, because I used -3, I have to use 5. I can't just swap it out. So I'm going to have this as 5 plus, we just still don't know what b is. That's what we're solving for. So I'm going to multiply. I'm going to simplify this. I'm going to evaluate to solve for b. So I'm going to do the math that I can do. So I see -6/5 multiplied by 5. I can do that operation, okay? There's no letters in my way. I can do that math. So if I take -6/5 times 5, I'm going to ask my Google here because I don't have my calculator. Hey, Google, what is -6/5 times 5?
The answer is -6.
So the answer is -6. Thank you, Google. I knew what that answer was. I've already done this. But so these two would have canceled out, left me with -6. So I have -3 equals -6 plus b. So to solve for b, so I need to figure out what plus -6 is going to be -3. So if I'm solving this equation, I could use my calculator, I could plug this in, or I can go old school here, no calculator. I would have to do the opposite. Opposite of -6 is adding 6, or +6. I'm kind of bleeding here into the other side, so I'm going to kind of arrow this over here. So -3 plus 6. So -3 plus 6 is going to be a +3, and a +3 equals b. So the value of our y-intercept is 3. So if I'm writing this equation, y equals what, x plus what, we're leaving the y in x. We've said our slope, our m value, is -6/5. So here's -6/5. And because again, we found that in task 3, and we just found what our y-intercept is. Our y-intercept is 3. Just to be on the safe side, I want to see how accurate that is. So I'm going to go back to my graph. I'm going to come here to my graph. Here it is. And I'm going to see, they're saying my y-intercept is 3. So a y-intercept of 3 would be right here. Is it going to cross right here? Well, let's find out. So if I line this up, if I was to extend this line, would it cross over the y-intercept at 3? Yes, it would. 1, 2, 3, and it would cross over there at 3. So that was accurate. Okay, so I found the y-intercept with actually having to not look at the graph. I did it using the equation and using one of the endpoints. So to find the answers to task 7 for writing those linear equations, again, you're going to want to use task 3. You're going to have to use the slope that you found in task 3. You are going to use y equals mx plus b. You're going to plug those slopes in here. Pick an endpoint, one of the endpoints. So if like you're doing security desk to water slide, use the ordered pair for security desk, plug in your x and y values there, and simplify to find the b value. And then double check on your graph to make sure your answer is correct. Make sure that if you got, a +5, that, yeah, you know what, that is going to cross over at +5, okay? So this was task 7, writing linear equations for our fictional water park. Have a great day, guys. Bye.